This is the November 2014 calculator higher tier GCSE paper, and we're looking at how to get up to a grade C on this. We're not looking at every single question. And a grade C was 29 marks, grade B 48 marks, and if you've been in my class this year, then there are 50 marks worth of material that we can cover if you've just done all the stuff that we did in the lessons. If you did some of the extra homeworks and so on, then there's another 16 marks worth at least that we can do. Apologies as usual for the poor handwriting on the iPad and for the slightly croaky voice. I've got a bit of a cold this week, so here we go. So, question 1, the ingredients needed to make 10 pancakes are here, and we are being asked about what do we need to do if we're going to make 30 pancakes. Well, this is just a recipe type question, or a proportion recipe question if you like. So to get from 10 to 30 we times by 3. Remember, the idea here is the number in the question is 10, the number in the recipe is 10, the number in the question is 30, and how do we get from 10 to 30 just by timesing and dividing? Well, in this one it's dead simple, we just times it by 3. So we need to work out how much flour we use, and we do the same calculation with the flour. 120 times by 3 is going to be 360 grams of flour. So 360 grams for 2 marks. And you can think about that, 10 pancakes, 3 lots of 10 is 30, so we're going to need 3 lots of the same amount of flour there. Now, Tara makes some pancakes. She uses 750 millilitres of milk. Work out how many pancakes that is. Well, let's have a look. 750 millilitres of milk. So in the recipe, we've got 300 millilitres of milk. So we need to work out how to get from 300 up to 750. And again, we're only allowed to use timesing and dividing in this case. So I think the way we could do it is we could half it, or divide by 2, and that gets us to 150 millilitres. And then if you do 150 times by 5, then we get up to 750. Of course, you could do 300 and divide by 6 to get to 50, and times that by 15 to get to 750. You could, if you want, do 300 divided by 300 and get down to 1, and then times that by 750. This is, after all, a calculator paper, so it doesn't matter if the numbers get a bit tricky for us to deal with. But I'm going to go this way, half it and then times by 5, and work out how many pancakes she's made. So the recipe says 10 pancakes. If we half that, divide by 2, then we get 5 pancakes. Times that by 5, then we get 25 pancakes, and that is how many she's made. It's a scatter graph. Before we even read the question, before we do anything else, we always, with the scatter graph, get the ruler out and put a line of best fit on there. Now, I've not got a ruler that I can use on the iPad, but you have a ruler in the exam, so stick that on. Describe the relationship between the length and the width of a pine cone. Well, this is a line that's sloping upwards, so we want to say a positive correlation. That's what we're looking for here for the mark there. Positive correlation. Estimate the width of this, another pine cone from this tree has a length of 8.4 centimetres. Estimate the width of this pine cone. So if the length is 8.4, we go along to 8.4 on the, there we go, let's get the pen, 8.4 on the length axis. We draw a line all the way up to our line of best fit, which we've already put in place. And then when we hit the line of best fit, we go across. And you would want to be using a ruler so you don't have a nasty, horrible, wobbly line like I've got here. But our answer there is 6. And then we're 2 squares above the 6, so do watch out. From the 6 to the 7 is 10 little squares. So each little square in this case is worth 0.1, so it is 6.2. Just looking at the mark scheme here, anything between 6.1 and 6.4 will get you a mark. Now, this sort of question comes up quite a bit, and if we just have a look at this, there are several parts here. Some of them are easy, some of them are tricky, and they're all algebra-based things. So let's have a look. Let's find the easiest ones first. I think the easiest ones are probably these ones down at the bottom. Just can we remember the indices rules? If we're timesing with indices, we add the powers, so m to the power of 8. If we're dividing indices, we take away the powers, so p to the power of 4. So that one we can definitely do. Part B, if you're happy with factorising, this is probably the next easiest. We take the biggest number we can out of the first bit and the second bit. The biggest number we can take out of both is a 3. We can't take any letters out of the front and the first term and the second term, so we can just take a 3 out, so 3 times x, and then 3 times 2. 3 times x to give us 3x, 3 times 2 to give us 6. That's the first one with a dotted line around it, because not everybody's done that this year. There's only if you made sure you did all the work that I set and some of the extra homeworks and so on. So work out the value of f when g equals -5 and h equals 2. Now this is a bit of a tricky one, but we can have a go at this. All we need to do is when g is, so well, in here we say 3g, that means 3 times g, and 7h, that means 2 times h. So f is 3 times -5 plus 7 times 2. And here we go, well, f is 3 times -5 is, well, positive times negative is a negative, 3 times 5 is 15, 7 times 2 is 14, minus 15 plus 14 is going to be -1 there for the answer. And that leaves us with this part C, which I think is probably the trickiest, and it, let me just get rid of that so we can see this bit. Expand and simplify. Well, expanding brackets, remember, you've got to do the thing in front of the brackets times everything inside the brackets. So 5 times y is 5y, 5 times -2 is -10, and then this 2 is in front of this bracket here, so 2 times y and 2 times -3 is -6, and then we've got 5y's and 2y's, so that's 7y's, -10 -6 is -16, 7y -16 for the answer there. Question 4. This is asking us about reflecting shapes. As soon as you see this, make sure you get your tracing paper. You are allowed tracing paper in the exam, but you might have to ask for it. So get some tracing paper and have a go at this one. The idea is you're reflecting this shape in this line here. So let's look at one point there. We go half a square to the line, half a square to the other side, and that's where that corner is going to end up. And then that goes 1.5 squares to the line, a half square, and another square, so 1.5 squares this side. And we do that for all of the points on the shape. Now, that's my guess then, where I've just put that, that shape in there is my guess at the answer. But make sure that in an exam, get your tracing paper and you check your answer. It's very easy, particularly under the pressure of exam, to just make a little slip and get one of those points wrong. So, check it with tracing paper. Describe fully the single transformation. Now that has to be one transformation. So what are our transformations? Rotations, reflections, translations, and enlargements. Now, it can't be an enlargement because both of these shapes are the same size. So we're left with rotations, reflections, and translations. Well, rotation would be where we turned it around. Well, shape B hasn't been turned around to get to shape C, so we can cross that off. Is it a reflection? Have we reflected it in a line? Well, no, we haven't. So it's a translation, that is a slide. We've just slid shape B along till it's got to shape B. How far have we gone? We've gone 1, 2, 3, 4 across and 1 down. So we need to say it's a translation. Now, if we say 4 across and 1 down, we won't get marks. We need to write it in a vector. The top number is a 4. The bottom number is a -1. Because the top number tells us left and right, the bottom number tells us up and down. Down is negative, so -1. Right is positive, so a +4. Okay, so you must write it with this thing which we call a vector. So a translation by the vector 4 -1. If you just say 4 across and 1 down, you won't get the marks there. Question 5, there are some green counters, some yellow counters, some blue counters, and some red counters in a bag. And this table shows the probability that a counter taken from the bag will be green, yellow, or red. So what's the probability of getting blue? Well, there's one fact to remember here, which is these numbers have to add up to 1. So 0.16 plus 0.4 plus 0.24 plus something makes 1. Now, we've got a calculator here, so it's not going to be too tricky to tap this in and work it out. But we could do it without as well. 0.16 plus 0.4 is 0.56. 0.56 add 0.24. 6 add 4 is 10. 5 add 2 is 7. Add 1 is 8, so that's 0.8, so that makes the probability of getting a blue 0.2. Mary puts the counter back into the bag. Okay, so we're back at this situation. Here are the probabilities of getting these different colours. There are 125 counters in the bag. Work out the number of green counters. Now this has got dotted line around it here, the dots around this part B, because not everybody was comfortable with this when we did it in lessons, but if you can remember this bit, what we've got to do is we've just got to do this 125 times the probability of getting a green. So 125 times 0.16, and this is a calculator paper. You tap it in the calculator, and that is going to get you 20 as an answer. We'd expect 20 green counters. Excuse me. Now Margaret is on holiday in France. She buys an English newspaper. The cost of the newspaper is €5. In England, the cost of the same newspaper is £2.50. The exchange rate is £1 is 1.16 euros. Work out the difference between the cost of the newspaper in France and the cost of the newspaper in England. Well, remember, if you're going from pounds to euros, you times by the exchange rate. So £2.50 times 1.16 is going to give us how much this that is going to give us £2.50 in euros. So I'm typing that in the calculator now. That gives us the answer 2.9. In other words, €2.90. In France it costs €5, so how much more is that? So we need to do €5, take away €2.90 is going to be €2.10, or 2.10 euros, so €2.10. Question 7. This is an arithmetic sequence, and a bit of a tricky question, but we've done this lots of times now, so hopefully we get the idea. We write the sequence out, and above that we're going to need to know that this is the first term, the second term, the third term, the fourth term, the fifth term. Here's the sequence, and that is n. So we look at the sequence and it goes up in fours. So what else goes up in fours? Well, the 4 times table. So if this top row is called n, then the 4 times table is 4 times n. So 1 times 4, 2 times 4, 3 times 4, 4 times 4, and so on. And then how do I get from the middle row to the bottom row? Well, if you look at it, I take away 2 in every space. So 4n take away 2, and there is our answer. 4n take away 2. Make sure you put that down on the answer line. Is 86 a term in this sequence? And you must give a reason for your answer. Now, that's a bit of a tricky question. There is one obvious way that we can do it, which is just keep writing this sequence down until we get all the way to 86. Now that's quite a lot of work. It's not the best way of doing it, but it will get us the mark. So if we've got time at the end of the exam, we can have a go at that. That's for the reason it's got dotted lines around this. The other way of solving this question is to say, well, if it is a term in the sequence, 4n minus 2 equals 86. And n, remember, has to be a whole number because it has to be the first term in the sequence, or the second, or the third, or the fourth, or the fifth. You can't have the 7.5th term in the sequence. That doesn't make sense. So we'd solve this equation, and if n comes out as a whole number, then the answer is yes. If n comes out as not a whole number, then the answer is no. So let's have a look. Something take away 2 is 86, so that something has got to be 88. 4 times something is 88, so n is 22. So if we let n be 22, if we do 22 times by 4 and take away 2, we get 86. So in other words, 86 is in the sequence, so yes, it's the 22nd term in the sequence. Don't worry if you're not following that one, that's not for everybody. One of the harder questions there. If you are just aiming for a grade C, we don't need to be able to get that particular mark. It's a lot of work for 1 mark, that we can pick up those marks elsewhere. Remember, there's 50 marks we can get on this paper, there's only 29 marks needed for a C. This frequency table gives information about the heights of some people. There's quite a lot on this paper about frequency tables, by the way. So we want to draw a frequency polygon. It says here in the question, there we go, frequency polygon. Now for a frequency polygon, we need to add on the midpoint column. So we need to know the midpoint of these heights. I'm going to add it on the left-hand side here. and the midpoints are, well, 162.5, 167.5, because halfway between 165 and 170. So not too tricky to work out in this case. 172.5, 177.5, 182.5, and 187.5. And those are the numbers that we're going to plot against these frequencies. So let me just resize that screen. There we go. So frequency is on this axis, height is on this axis. So we're going to go for 162.5 against a frequency of 2. So again, look at the scale here, 160 there, 165 there. So halfway between the two is halfway along this square here. And we're going up to a frequency of 2, which is just here. Again, I'm looking at the frequency. Here's 0, at the scale. Here's 0, here's 10. There's 10 little squares in between. 167.5 goes against 5. And then the next one is going to be a 10, and a 21, a 16, and a 4. Now, if you remember, a frequency polygon is the only time we go dot to dot with a ruler. Now, I don't have a ruler on this iPad, so you're just going to have to take a sloppy answer here, but on your paper it should be with a ruler, okay? Any other graph, you're going to join it up with a nice smooth curve if you had a shape like this, but if it says a frequency polygon, we join it up with straight lines. You might remember the word polygon means a shape with straight lines. Bit of a tricky one, this, but there's no reason we can't get the marks here. We're just going to have to think quite carefully. So the table gives some information about student attendance on a Friday. So here are the years that the students are in here. This is how many were present, this is how many were absent, this is the total number of students. The school has a target of 94 students being present each day. Did it meet its target on Friday? So 94% being present. So the one way of doing this is we could work out how many students were present, what's the total number of students present, and we could work from there. So that's what we're going to need to do. So how many students are present? Well, that's 192 plus 219 plus 234 and so on. So I'll just type that in the calculator. 192 plus 219 plus 234 plus 233 plus 214 is 1092. That's the total number that are present, and the total number of students that exist is over here, 208 plus 241 plus 262 plus 261 plus 238 gives us a total of 1,210. Now, that's a little bit not very good here in the way that I've set this out. If we were in a GCSE exam, we'd want to say total number of students, the total present was 192 plus 219 plus 234 and so on, so that show the examiner what calculations that we've done. But since I'm talking you through this, I'm being a little bit sloppy there. So we've got 1092. Is that more or less than 94% of the total number of students? Well, one way of doing that would be to work out 94% of 1,210. One way of working out 94% of 1,210, well, it's a calculator paper, remember, so we could work out 1% and then we could times it by 94. So 1,210, 1,210 divided by 100 is going to give us 121. Oh, sorry, it's going to give us 12.1. 12.1 times by 94 is going to give us 94%, which is 1,137.4. So is this more or less than this number here? And that's more than this, than 1,090. Oh, sorry, it's less, isn't it? 1,092 is less than 1,137. So they didn't meet the target on that Friday. There are some other ways of doing that question, but I think that's probably the way that fits in with the way that we use percentages the most in our class. Now, this one is a trial and improvement question. The equation x cubed minus 2x equals 125 has a solution between 5 and 6. And we need to find a solution to one decimal place and show all the working out. Now, if you get the right answer but no working out, you get 0 marks on this one, so make sure you show your working out. Easiest way to do that is like this. We're going to have a guess. Now, we know it's between 5 and 6. We don't need to try 5 and 6, so I'd start with 5.5, halfway between 5 and 6. And then we're going to work out x cubed minus 2x. So that is going to be 5.5 cubed minus 2 lots of 5.5. And if we type all that in a calculator and work it out, we're going to get 155.375 and some other things as well. Okay. Now, we were looking for 125. So this answer, this column here, is for our comment, and that is that this is too big. So we've got to go down from 5.5. So this looks like quite a bit too big to me. So I'm going to go all the way down to 5.2. Now, if I try 5.2 and I do all the same working out, 5.2 to the power of 3, so 5.2 cubed, take away 2 lots of 5.2, and I'm getting, out of the calculator this time, 130 point something. But they're still too big. So I'll go down to 5.1, excuse me, and do all the working out, and I get 122 and some other stuff, so that is too small. Now here we're up to 3 marks out of 4. But we've narrowed it down to this situation. I know that the answer is between 5.1 and 5.2. The question says give the answer to one decimal place. Well, which of these is it closer to? Is it closer to 5.1 or is it closer to 5.2? And at the moment we don't know. We can't tell by looking at these numbers here. It doesn't matter that 122 is closer to 125. We can't sort of rely on that. So what we're going to have to do is we're going to check which is it close to. Is it close to 5.1 or 5.2? Well, let's try halfway between. Well, that would be 5.15. If we try 5.15, then that would do all the working out, and we would get a number of 126.2 and so on. So that is too big. So I know that it's 5.1 is too small, 5.15 is too big, so I can cross this bit out, and my answer is somewhere in this gap here. In other words, it's closest to 5.1. So my final answer is going to be 5.1. X equals 5.1 to one decimal place. Safia is organising a conference. People at the conference will sit at circular tables. Each person has a diameter of 140 centimetres. Each person needs 60 centimetres around the circumference of the table. There are 12 of these tables in the conference room, a total of 90 people. Are there enough tables? Okay, so the first thing we need to work out is how many people can sit at one table. So each table has a diameter of 140, but the people don't sit across the middle of the table. If we look at a table from above, people don't sit across the middle, they sit around the outside. So we need to work out the distance around the outside. Now that is the circumference. So the circumference is, the way that we've done it this year, is 2 times pi times radius. Well, if the diameter is 140, the radius is 70. So the circumference is 2 times pi, which is 3.14, times 70. And we type that in the calculator. 2 times 3.14 times 70, and we get the answer 439.6. Each person needs 60 centimetres, so how many people can fit around the table? Well, that's going to be 439.6 centimetres divided by 60 centimetres will tell us how many people. So 439.6 divided by 60 is giving me an answer on my calculator here of 7.32666 recurring people per table. In other words, 7 people. We can't get 7.32 people, so it's it's not enough for 8 people, so it's 7 people per table, i.e. 7 people per table. And again, apologies for the handwriting on this iPad. So there are 12 of these tables in the conference room, so at 12 tables we can fit 7 times 12, which is, well, I'm typing that in a calculator. You probably know your 12 times tables, so we don't need to type that in a calculator. So 84. There are a total of 90 people at the conference. Are there enough tables? Well, we can fit 84 people in. We want to fit 90 people in. So the answer is no, not enough room, or something like that. Okay, so we're being asked to draw a graph on a grid, and they're making it a bit mean here because they haven't given us the table of values. So we'll have to draw our own table of values in, and they haven't even drawn the grid on the axes here. So here we go. X goes from -2 to 3. So -2, -1, 0, 1, 2, 3. And how do we, if we know x, how do we get y? Well, 2 times x and then take away 3 is what it says in the question. 2x minus 3 means 2 times x and then take away 3. So I'm going to start here with the easiest one. 2 times 0 is 0. Take away 3 is -3. Oops. When x is 1, 2 times 1 is 2. Take away 3 is -1. When x is 2, 2 times 2 is 4. Take away 3 is 1, and so on. So if we fill in the whole of the rest of this table, we end up with this situation here. Then we have to go to our grid. Our x values go from -2 all the way up to 3, but our y values are going from -7 up to 3. So our y-axis needs to go all the way down to -7 and all the way up to 3. Let me just resize this a little bit. Here we go. So let's draw our x and y axes in. There we go. Oh, that's even for a bit of a scruffy answer. That is too scruffy. We need to try and make sure our x-axis is roughly on the line. Obviously, in the exam you'll have rulers and so on. So 1, 2, 3, -1, -2, -3, and then -1. The y-axis needs to go all the way down. So this is our x-axis here. This is our y-axis here, and it needs to go all the way down at least to -7. So there we go, and all the way up at least to 3, and we've got a bit more space there. So when x is -2, y is -7, so we can go there. When x is -1, y is -5, and that would be there. 0, -3, 1, -1, 2, 1, and 3, 3. So we've got all our points there, and if we look at it, they're all forming a nice, neat straight line, which of course you would join up with a ruler, and once we know it's a straight line, we keep it going off both ends of the grid, and we'd label it with the equation y equals 2x minus 3. Now, this diagram shows a swimming pool in the shape of a prism. So as soon as we see prism, we're thinking, okay, volume and surface area. The volume is the area at the end times by the length, and the surface area would be look at all the faces separately and add up the areas of them. So let's have a look. The swimming pool is empty. The swimming pool is filled with water at a constant rate of 50 litres per minute. So there's a number that we need to have a think about. Work out how long it takes for the swimming pool to be completely full of water. Give your answer in hours. And it tells us that 1 metre cubed is 1,000 litres. So let's have a look at the total volume of the thing first of all. And the way I'm going to work out the volume is I'm going to look at the face here, and I'm going to split it up into two areas, A there and area B here. And that means that this length on shape B is 9 metres. Now this is quite a tricky question, but area A equals 1 times 6 is 6 metres. If we get that far, we've got a mark, all right? For shape B, you might recognise it. Let's just draw this out, over here. It is actually a trapezium. That's 1 there, that's 2 there, and that's 9 metres there. Now, if you're not happy dealing with trapeziums, you could split it up into a rectangle and a triangle. I'm going to go straight ahead with the trapezium, though. So area B is add together the parallel sides. So that's 2 plus 1 is 3. Half it, which is 1.5, and then times the answer by the distance between the two sides. So it's 1.5 times 9, which is going to be 13.5 metres squared, isn't it? 13.5 metres squared. So the total area at the end is 6 plus 13.5, which is 19.5 meters squared for the area at the end. Here we go. So 19.5 meters squared is the total area. Now, if we times that by 10, we get the volume, because the volume is the length of this prism. So 195 meters cubed is the volume, and if we look at this bit here, times that by 1,000 and we get the number of litres. So the volume in litres is 195,000 litres. Now if we do 50 litres per minute, we want to know how long it fills up in hours. So we need to know how many litres in an hour. So it's 50 in a minute, so 50... I do apologise for my child crying. Please don't be distressed. My wife is tending to his needs, trying to calm him down. So 50 times 60 is, 5 times 6 is 30. So 50 times 60 is 3,000 litres per minute. So we've got 195,000 litres and 3,000 litres per, did I say per minute? Per hour. 3,000 litres per hour. So how many hours does it take? Well, that's 195,000 divided by 3,000. And we could tap that in the calculator straight away if we like. 195,000 divided by 3,000. And I'm getting the answer here, 65 hours. Part B is a bit tricky, but it is a multiple choice question. So I've not circled it. It's not really one that I'd expect us to be able to have a think about it, but read the question, see if you can have a go. If you look at those graphs, you might be able to work out a way of doing it. And if you're not sure, have a guess. You've got a 1 in 4 chance of getting it right. If you've had a go and had to think about it, the answer there, by the way, is C. Okay. Now with this one, it's compound interest is something we haven't done for quite a long time. We did do it, everybody's done it at some point, but it's not something we've strictly speaking covered this year, so I'll put a dotted line around this. Even without compound interest, though, we can pick up some marks on this question. There's a total of 4 marks here, so we should be able to get some of them. And let's have a look. As usual with these things, we need to work out the bonus. There's 2 situations. There's a bonus saver and there's a fixed rate. So let's have a look at the bonus rate saver on the left-hand side. And what happens is we have £20,000 for 2 years. So 4% in the first year and then 1.5% after that. So 4% of 20,000, well, we can do 20,000 divided by 100 and then times by 4. And that would give us £800 interest. So after the first year, we've got £20,800, and then we need to add on 1.5% of that. So £20,800 divided by 100 and then times by 1.5 is giving me 312. So after the first year, I get a total of 1.5% of £20,800 is 312. So after the first year, I get a total of £21,112. Okay, so that's our first year there. Let me just double check that. Yes, that's looking good. Now, if we've got a fixed compound interest rate of 2.5, then that would mean, now there is a quicker way to do this, but we could work it out this way if you're not happy with compound interest. 2.5% of 20,000, we'll work that out. So I'm typing in my calculator, 20,000 divided by 100 times 2.5. And I'm getting out the answer 500. So after the first year, I've got £20,500, and I need 2.5% of that. Sorry. I work that out and I get £512.50. So after the 2 years, I get £21,012.50. Sorry, £21,012.50. 210. So, oh, sorry, I've written that wrong. Hang on, 21,000. So £21,012.50. So the zero is just slid off the end of the screen there. But we've got these two amounts to compare. So which is the best? And the best is the bonus saver. Whichever one of these questions you do, make sure you actually give the final answer. Do say the bonus saver, therefore, is the best. We're going to miss question 15 out, bit of a nasty one, question 15, but you might even be able to have a go at it just by guessing and trying some numbers and seeing what you come up with. If you did have a go at question 15, by the way, the answer was £8.50 and £4.50. Question 16, really tricky one. We're not going to get all the way, but we can make a start. So this is the way we go about this one. We're asked to find out the length of all four of these metal bars put together. Now, we aren't going to be able to find this one here, but we can do this length A to C, and if you look at this, just the red lines that I'm drawing in, what we've got there is a right angle triangle. So we are going to use Pythagoras' theorem. So let's draw our squares on first of all. We've got 3 squares here. We've got a little square which has got an area of 9, a medium-sized square which has got an area of 25, and that means that the big square here has got an area of 34, and these are in meters squared. And so the length that we're looking for here, we've got to do the square root of 34. Type the square root of 34 into the calculator, and we're going to get square root 34, 5.8. So if you get square root of 34, if you write that down, or if you write down 5.8, well, I'm going to go 5.83. In my calculator, it says 5.830951. So do round it to a sensible amount, usually 3 significant figures. And that will get us a couple of marks. There probably at least 2. In fact, let me just check the mark scheme. Question 16. That will get us 2 marks. Yeah, 2 marks there out of 5. So the rest of the question gets a bit tricky, not stuff that we can really cover, so we'll move on. Not a question that we're going to have a go at here. If you run out of time on the other questions, you might want to have a crack, but not one that we've covered. Question 18. The table gives some information about the length of time in hours that some adults watched TV last week. Work out a mean length of time. Well, you just have to remember this one. Can you remember how to find the mean from a group frequency table? What we've got to do first of all is add on the midpoint column, and that is the midpoint of these things here. So, and this, remember, is the column that we call x in this case. So from 0 to 10, the midpoint is 8. From 10 to 15, the midpoint is 12.5. From 15 to 20, it's 17.5. From 20 to 30, it's 25. From 30 to 50, it's going to be 40. And then we need the f times x column. That is the frequency times the midpoint. So 8 times 5 is 40. And then 15 times 12.5 is, we'd type that in the calculator and we get 187.5. And 17.5 times 11, or 11 times 17.5, 192.5, and so on. So 250 in here, 240 in here, and we then need the total of the f times x column, and we divide it by the total of the f column. Just a fact that you've got to remember, I'm afraid. So if we did the total of the f times x column, that's this one here, you should find there that you get 910. If you do the total of the frequency column, we should get a total of 50. So our final answer is the total of the f times x column, 910, divided by the total of the f column, that's 50, and that would give us 18.2 for the marks there. For a histogram, so I'm looking at part B now, we need to remember that we need the class width, so that's the frequency, sorry, not class width, we need the frequency density, that's frequency divided by class width. Now I'm running out of space on this side of the table, so I'm going to go over here. So frequency divided by class width, well the class width here is 10, so 8, so the frequency, frequency density, FD for frequency density, 8 divided by 10 is 0.8. 15 divided by 5 is going to be a frequency density of 3. 11 divided by 5 is going to be frequency density of 2.2, and so on. So 10 divided by a gap of 10 there is 1. 6 divided by a gap of 20 is going to be 0.3 or thereabouts. It's 0.3333, but you know 0.3 will do for us, I think. And then we just need to draw on here essentially a sort of bar chart style thing with those numbers involved. So we always remember that the frequency density goes on this axis up here, and our frequency density has to go all the way up to 3. So conveniently 1, 2, 3. There we go. From 0 to 10 in hours has a frequency density of 0.8, so that would go like that. From 10 to 15 has a frequency density of 3, so all the way up to 3 from 10 to 15. From 15 to 20 is a frequency density of 2.2, so 2.2, here we go, and there it is. Oh, a bit wobbly here. Obviously you'll be using a ruler. I haven't got a ruler on this app here. So from 20 to 30 we have a frequency density of 1. And from 30 to 50, frequency density of 0.3. So 0.3. There we go, and there is our finished histogram. Make sure we label this axis. FD is a bit sloppy, really. We should write frequency density on there. And the last question which we can try on this paper. Now, Louise makes a spinner. The spinner can land on green or red. The probability that the spinner will land on green is 0.7, and she spins the spinner twice. So the first time she spins it, if it's going to land on green or red, if the probability of green is 0.7, the probability of red then must be 0.3. The second time, the probability of green is still 0.3, so the probability of green is still 0.7, so the probability of red is still going to be 0.3, and that's going to be the same down here. So 2 marks for that. That's quite a nice question for us, I think. Now, work out the probability that the spinner lands on 2 different colours. So we need to look along the branches. Let's have a look along this branch first of all. That's landed on green and then on green. So we can forget that branch, we're not interested. Here we've landed on green at the first spin and red at the second spin. So we are interested in this branch. Here we've landed on red and then green. So we are interested in this branch. And the final branch we've landed on red and then red. Well, that's not different colours, so forget that. So we need these 2 branches here, and remember you times along the branches. So here 0.7 times 0.3, 0.7 times 0.3, and here 0.3 times 0.7, 0.3 times 0.7. So we work those 2 things out, and then we add them up together. So 0.3 times 0.7. Well, we could type that in a calculator if we want. I don't know why I'm doing that. I know the answer is going to be 0.21, but I've just checked on my calculator and it's confirmed it there. And obviously that's a good thing to do if you're in the exam, even if you know the answer. If you've got a calculator, check it. So 0.21 for each branch. Add those 2 things together, and we get 0.42 for 3 marks. So the key there is, remember, find the branches that you want, times along the branches, and then add up the branches. Sometimes it'll only be 1 branch that you want. So you've finished. So there's a lot there, even right the way up to question 19 that we can answer. The last few questions are grade A and A star things, so we're not worrying about those aiming at B's and C's. So that is the lot on this paper.